Hi, my name is Zhang and this is my partner Erzheng. Our project is a parallel Monte Carlo simulation engine written in C. We'll demo the pi estimation feature which distributes simulation work across multiple worker processes using pipes. Here's the program running with 4 workers, 16 jobs, and 10k trials per job. The program forks 4 worker processes, distributes 16 jobs across them round robin, and collects the result. You can see the aggregated output here, total successes, total trials, and the final pi estimate. Let's quick it up to see the estimate get more accurate with more trials. Closer to pi, all of that work happens in parallel across 4 processes. In addition to pi estimation, we also implemented a Bootstrap main estimation feature that reads data from a file and distributes the resampling work across multiple worker processes using pipes. Here's the input file that we use for this demo. Now we will run the Bootstrap simulation with 4 workers, 8 jobs, and 5,000 trials per job. The program first reads the data from the file, then forks 4 worker processes. It distributes 8 Bootstrap jobs across some round-robin through pipes. Each worker repeatedly samples from the dataset with replacement, computes partial statistics, and sends those aggregated results back to the parents. The parents then combine everything and prints the final output. The estimated mean is very close to the true mean of the dataset, which is 17.4. Let's crank up the number of trials to make the estimate even more stable. With more total samples, the Bootstrap's estimates stay close to the true answer, and the standard error gets smaller. All of that work still happening in parallel across 4 worker processes with the parent's coordinated job, dispatch, and result collection through pipes.
Now let's look at how the pipe communication actually works. There are 2 types of messages, as defined in protocol.h. The parent sends a job message T to each worker. It contains the job ID, number of trials, and simulation type. The worker sends back a result message T with the partial results. Each worker gets its own pair of pipes, one for receiving jobs and one for sending results. That's set up here in pipes.c. 2 pipes per worker. After fork, each process closes the ends it doesn't own, so EOF is detected correctly when the parent shuts down. The parent dispatches jobs here in parent_controller.c. See the show dispatch jobs, the round robin loop. Job J goes to worker J, mod worker count. Each job is written as a fixed size binary struct using write full in protocol.c, which loops to guarantee all bytes are sent. After dispatch, the parent closes its write end, and that's the shutdown signal. Workers detect EOF and exit cleanly. Results come back here in collect results. The parent uses select to watch all worker-to-parent pipes simultaneously, so it never blocks on one slow worker while others have results ready. It loops until all jobs are accounted for, accumulates the partial sums, and prints the final estimate.